Hey everyone, welcome back. Today I want to share something with you that I think is interesting, hopefully, and informative, hopefully, and also fun, I think. As you know, I've been making these videos for several months now, and we've explored different topics such as setting up different development environments and exploring different programming techniques in Z80 assembly language and machine code and BASIC. And we've been looking at several different aspects related to game development for the Sinclair Spectrum computers and the ZX Spectrum Next computer, which is my ultimate goal. And since we haven't actually used any of these techniques to make a game yet, I thought it would be fun to actually make a complete game from beginning to end. And we can take a look at that process together to see how these pieces kind of fit together in our journey. And actually the point of today's video is not really to teach you or have a tutorial about programming techniques to actually create a game in particular, but rather I'm going to share with you a method that I came up with for actually doing the game development process. So it's my workflow that I'm going to be sharing with you, because in developing games, there are a lot of people developing games, and there are people who have been making games for several years, and now there are even more people making games, particularly for the Sinclair ZX Spectrum Next computer, because it has all these cool upgraded features and capabilities. And so there are a lot of people, I think, interested in making games. And if you're interested in making games but maybe don't know how to exactly go about it, maybe it seems kind of daunting to figure out what steps to take in order to make a game from beginning to end, that's exactly what we're going to be looking at today. At least we're going to be looking at my workflow process that I came up with. And I'm not saying this is the best process to use. I'm obviously not a professional game developer, at least not yet. But I have come up with a process which I think will work. At least it seems to work for me. And so I thought I would share it with you. Now, why is it important to have a workflow process in developing games to begin with? Well, I think a lot of people probably, when they start building a game or developing a game, they might have a tendency to sit down at the keyboard and just start typing away, creating some code. It's always more fun to start working on the exciting aspects of game creation, like designing some graphics and making things move around on the screen. So there's a temptation to just sit down at the computer keyboard and start typing away and building a program from scratch. However, this has at least a couple possible disadvantages when it comes to actually creating an overall game. Well, for one thing, something which I think is probably the most important feature of a game is actually getting it finished and completing the game so that we can send it out there in the world and make it available for other people to play, and other people can actually enjoy our games. So I think a lot of people might have a temptation to start building a game, start working on a game, and then they get all excited about it and they work on the fun parts of the game, like the graphics and the mechanics and the movement, but they might never actually finish the game because we don't have a plan in place or a strict workflow set up ahead of time. So I think it's very important to set up a workflow that we can begin with, which will outline the structure of the program, and it will serve at least one purpose, which is to let us know when our game is finished. So we have a strict outline set in place, and it contains all the features and different aspects of the game, which we'll go over in today's video. And once these features and aspects are in place, then we know our game is finished, and we don't have a tendency or a temptation to just continually keep adding more and more features to our game because we're just sitting at our keyboard creating code endlessly and never end up with a finished game. So that's one aspect we want to achieve, is to actually create a finished game. And when we have a workflow, we can actually add timelines to it if we want. If we want to have a schedule for our game, then we can actually create timelines for performing and completing certain tasks if we want. Now, the other negative aspect in just sitting down and coding a game without first creating a structured workflow is that it's very easy for the code to get messy. And particularly in BASIC, which uses line numbers, as you know, which is probably the worst feature of any programming language, is to have line numbers, because they're just I don't know what the person was thinking who invented BASIC, but line numbers is a terrible, I think, feature of BASIC for us to have to work around, because we don't necessarily know how many lines it's going to take to create any particular section of our code. And we have to probably resort to things like renumbering our lines, and it can get very messy very quickly. And so whether we're using actually BASIC or not, if we don't start off with a structured workflow and game outline, then it can be easy to end up with a very complicated program that doesn't really make it easy to troubleshoot and easy to modify and easy to really see what we're doing when we come back to the code later. So in today's video, when we go through my workflow, we're going to be setting out all of the outline pieces that will make it very easy to first of all create our game in the first place, as well as we'll be able to modify it and troubleshoot it and come back to it later and make any additions or modifications that we need to much more easily than if we had just started sitting down at the keyboard and coming up with a random program that might be kind of messy and difficult to work on. So if you're interested in creating games and you want to do it in a structured manner so that you know exactly what parts and pieces you want your game to include, and you want to start out from beginning to end and follow very structured, kind of organized, modular workflow that will make it easier for us to create our games, then you've come to the right place, because that's exactly what we're going to do. I'm going to share my workflow with you, and hopefully it can help some of you to at least get started on the road to game development. So if you're ready, let's take a look. All right, so let's take a look at my workflow that I've come up with for developing games, and we'll start at the beginning and we'll go right to the end, and we'll see what different steps are involved in setting up a game based on the workflow that I've come up with. Now today we're going to be using Sinclair Basic or Next Basic, whatever basic you want to use. And actually this development workflow will apply to developing games really for any computer on any system using any language, although different languages have different aspects to them that will require different steps perhaps than the ones I'm doing here. But really this development process should be widely applicable to different systems and different programming languages. But today we're going to be looking at developing a game using this workflow in BASIC, and we can see that actually BASIC is much more difficult to develop in, I think, than a more modular type of language such as assembly language, for example, because we're constricted to using line numbers, which can be a pain. But as you can see, today we're going to find a way to work around that and make it work with us by splitting up our game into modules, so that in case we need to modify the line numbers or renumber the line numbers or renumber the modules, it will be quite easy to do, because of course our game will be modular, and which means it will be broken up into small bite-sized modules. So if we first take a look at the workflow that I've come up with, and I'm using Microsoft OneNote to keep track of my game development tasks, and you can use whatever kind of note-taking app you like. I like OneNote in particular because it lets me set up these different lists and grids, and I can have checkboxes and different cool things that make it really easy to track a workflow as I check off the different steps. So if you want to follow along with me, let's take a look at what I have here. And if we take a look over on the right side here, you can see I have 5 different sections set up, and they're called Dev List, Overview, Assets, Variables, and Modules/Flow. And this is flow of the game. So we're just going to go through these one by one, and this is the order that I actually complete them as I'm developing a game as well. Although this is a very organic process, and you might think, well, what if I don't know all the information that's required to develop my game? I don't know maybe what all different characters I'm going to have in my game. I might not know all the different rules and different features and different elements in my game. I might not know all the different names of the different places and the different, maybe there's treasures in your games and different things you need to collect. There might be, well, obviously there will be different variables. And you might think, well, how do we know all that stuff ahead of time when we're creating the workflow like this? How do we know all the information that's going to go into it at the beginning? Well, the simple answer is we don't. But that's okay, because this is an organic process which lets us build on the game as we're creating it. And as you'll see, it makes it quite easy to work on and easy to be able to modify it as we go along and develop our game as we go along. But of course, as I mentioned, we want to end up with a structured game that has a fixed set of features and attributes that will allow us to follow a fixed game flow design that will allow us to actually finish our games and get them completed. So the first thing I want to do is take a look at the top section here, which is labeled dev list. And this is just a list of all the different points that I need to complete when creating a game. And we'll just go through it one by one here and see what's involved. So the top one here is an overview. So first I'm going to be creating an overview of the game, which includes the description of the game and different aspects of the game, and we'll take a look at that in a moment. And then the next thing I'm going to be doing is creating a list of assets, and then a list of variables, and then the flow of the game. And so there's all these different steps here that I've included in my task list, and I simply go through them one by one, and by the time I'm finished and got to the end of my list, my game is done. So let's go through and take a look at each of these items one by one, and we'll just go through as if we're creating a brand new game. So let's say I have an idea for a game, and maybe I want to make a Pac-Man style game, but I don't want to name it Pac-Man, right? So I'm going to call it something else. Maybe I'll call it Pac-Rat, which is the name I've given to this tab here, Pac-Rat. So I've come up with an idea for a game and a name for the game, and I'm calling it Pac-Rat, and it's a Pac-Man style game. So first I'm going to go to my overview tab here and take a look at the overview section of my workflow. So the first thing I want to do is have, well, I guess I could add the name of the game here if I know the name of the game. Of course, you might want to add your game name later at the end or at some point during your workflow. You might not always know the name of your game to begin with, but I just came up with a name and put it on my tab up here. But if you're not using Microsoft OneNote, you might want to name your file the name of your game, or however you want to record that. But I think here I'll just add another section to this list for the name of the game. So right here I'll put name, and I'll call it Pac-Rat. And what will this Pac-Man style game be like? And now I just want a very brief description, ideally a single sentence. I don't want to get too involved. I don't want to get into too much detail because I'm not describing the elements and the features of the game in this section. It's simply a brief description, something similar to what you would put on, let's say, the outside packaging of a game, or maybe a description of the game that you would post on a website or something. So let's see what my Pac-Man game will be like, or my Pac-Rat game. So, I called it Rack-Rat. That should be Pac-Rat there. That looks better. So in this Pac-Rat game, which is a Pac-Man style game, I want to have, let's say, a rat going around a maze. And since it's a Pac-Rat, it can collect items as it goes along. And once it collects all the items in a level, then the level is complete. So let's say we have a brief description of the game. The player controls a rat exploring a maze and collecting items. And maybe my maze will have some enemies in it, but instead of ghosts like the original Pac-Man game, maybe I want cats, right? Because cats chase mice or rats. And so I'll say, while avoiding enemy cats. And it doesn't have to be a very pretty description, well worded. I mean, we can always change the wording when we actually go to create the packaging or the real description for our online description of our game later. But this is just something to start off with. So there we have a simple one-sentence description of our game, which is pretty encompassing and tells us what the game is about. The player controls a rat exploring a maze and collecting items while avoiding enemy cats. That's pretty descriptive and pretty succinct and pretty complete as well. So now I have a section here called gameplay, and maybe I'll just highlight these so that we can see them a bit better. So I have a section here called gameplay, and what will the gameplay be like? Well, the player is going to control the movement of the rat through the maze by using the keyboard or the joystick, so I'll just make a note of that. Player controls the movement of the rat through the maze using keyboard or joystick. And since I mentioned that the rat will be collecting items as it explores the maze, let's just put a brief description of that as well. How will these items get picked up? Well, let's say they get picked up automatically just by running over them. I don't need to press a button or anything, and so I'll just make a note of that. Items get collected automatically when the rat touches them. And then how about a note saying when the game has been won or lost? So let's say the goal of the game is to collect all the items per level. And I think that's good enough for the gameplay because it's a very simple game. All we do is control a rat going around a maze collecting items, right? That's pretty much all there is to it. And let's see what is next now. So here you can see I have another section called base features. And I say base features as opposed to the next section here, which is possible extra features, because in order for this game to be considered complete and workable and playable, it needs to have at least a certain set of base features that we would consider the game to need in order for it to be playable. So these are the features that are absolutely necessary. So let's see, what features would we need the game to have? And let me just put bullet points here. And let's say the player explores the maze. And maybe there are, let's say, 10 items to collect per level. And maybe the player starts off with a total of 3 lives. And the player dies or loses a life when it gets touched by a cat. So I'll say player loses a life if a cat touches them. Now, how many cats do I want to have in my maze? Let's say we want 3 cats in the maze at one time, chasing the player. So I'll just make a note of that. Okay, and then if we want, we could even have maybe a note of how many levels we want. So you see, at this point in the process, we don't necessarily have to have the game completely decided in our minds exactly what all features we want. We can always add features later. But here, remember, our goal is to just add just enough base features that we consider to be absolutely essential or critical to have in our game. So are there any other features that I would absolutely want my game to have? Well, let's say I want to have a total of 5 levels for the player to complete. Maybe this is just a very small game I want to make with 5 levels. So I'll say 5 total levels in the game. And then the last thing I want to put here, I think, is the items that the player collects while they're exploring the maze. I want them to have unique graphics. So I'll just make a note of that. I'll say each item has a unique graphic symbol. And there, I think that's enough to start off with. Now, this is, I think, a good starting point to create a game. And we can always add extra features, like I say, later. But this is a list of the core features we need in order for our game to be considered complete. And now, if we have any ideas for extra features that we're not really sure if we want to include in our game or not, like let's say perhaps the cats might have changing speed based on different aspects, so I can make a note of that. Cats have changing speed. Maybe we want a feature that allows the rat to be able to chase the cats, like in Pac-Man, when they collect a power pill, then the ghosts turn blue and you can chase them and attack the ghosts. Maybe I want to add a feature like that later. Feature to allow the player to chase the cats. And what else could we have? Maybe there's a feature where there are particular items that the player could collect that give the player certain powers. So maybe I'll put a note about that. Special bonus items give the player certain powers when collected. There, so we have a game that has a description, a brief outline of the gameplay. It has some base features, just enough but not too many. And we've also started a list of some possible extra features we might want to add to the game later. But at first we're going to start off just by creating the core game without adding any extra features. So now that we have this done, we move on to our next section, which is assets right here. So what are the assets? Well, the assets are all the actual pieces of the game elements that we actually need to create. So for example, if we take a look here at the different sections I've listed here, I'll just zoom in a bit. We might need to create some text for our game. Any type of text messages that get displayed in the game, obviously we need to decide what text is going to appear in those messages. So I've just put a couple examples here, like on the welcome screen. If there's a welcome screen, there might be text that's written in the welcome screen. For example, I have welcome to the game, good luck. So we have some text that we might need on the welcome screen. And then if the player achieves a high score, we might need some text to display on the screen for that, as I've shown an example here. So for our high score congratulations message, it says congratulations, you have achieved a high score. And so we might have different text messages we need to create for the game. And so I have a section here where we can keep track of those. And then if you're creating sprites for your game, if your game uses sprites, then you might want to, well, you should create a list of sprites that you'll need for the game. So for example, this game won't be using sprites. The game I'll be creating today will be for a regular Sinclair Spectrum computer, which doesn't have a sprite engine, so I'll be using user-defined graphics. But if your game does have sprites, then you just make a list of the sprites. So let's say if you had a sprite for the rat, then you would put rat here, just like that. And then depending how your system keeps track of the sprites and what type of color patterns it uses and what size of sprites they are and so forth, you can keep track of the information for the different sprites however you see fit. And this is really just a checklist to make sure we actually complete these elements at some point. So we're just making a list of all the different elements we need. But for example, if let's say this is a 16 by 16 sprite, and you can see here I've got a grid of 16 squares across by 16 squares down. So maybe each one of these squares represents a pixel in the particular sprite, and you might want to include a value there that maybe includes the color offset or the color value. So you might want to enter color values, for example, maybe 128, 45, or maybe you want to use hexadecimal numbers. However you want to add information that is useful for you if you're creating your sprites, then you could add it here. But I'm not using sprites in my game, so I'll just get rid of this information for now. And my next section here is called tiles. So if you have tiles that you're creating for your game, you can create a list of the tiles. Like maybe there's a tile for a tree. Maybe there's another tile for a background. And maybe you have several different background tiles, and maybe background 1, background 2. So then you would make a list of the different tiles that you need, or you might just say tile set for background. However you think it's useful for you, we can just make a list of the different tile information that we'll need to create at some point. And you can put details here. Let's say maybe scrolling background. And background 1 might be, I don't know, clouds or something, cloud layer. Whatever you think is useful for you in keeping track of the different tile elements that you will need. My game doesn't have tiles, so I won't be using this section. However, my game will be using user-defined graphics, let's say. So here is a list of different user-defined graphics, beginning with graphic pattern A, which is character 144. And then here you can see I have a pattern showing here with its decimal value. So let's say I need graphic character A. Maybe that will be my rat. And if my rat is not animated, then I might just need one character for the rat. Or maybe you have drawings that use multiple characters. So for example, my second one here, maybe this will be the cat. And maybe the cat has multiple patterns, so I could put whatever patterns I want here. And then value, whatever the value would be. So you can list all the different user-defined graphics that you use in your game if you're using user-defined graphics. And remember, we don't need to actually create these graphics now. In fact, we don't want to create these graphics now. If we're using user-defined graphics or sprites or tiles or whatever we're using, right now we shouldn't be worried about actually creating the final version of our graphics. So we can just use placeholder graphics instead. So whatever the most simplest basic graphics we can create that we need just to test out our game, we should do that rather than spending time actually creating the final version of our graphics, because the graphics can be very time consuming to create, as I'm sure you know. So whatever the most minimal basic graphics that we can create that we can just use as placeholders, that's what we want to do now. So we'll enter all our graphics into this list. And then here we have a couple more sections at the bottom, one called sound effects and one called music. So we might have sound effects in our game. So maybe in this Pac-Man game, there might be a sound effect for when the player collects an item. So I'll put a description of that. Item collect, let's say. Sound when player collects an item. And then if you want, you can also put some technical details about this sound effect. So here, for example, you might put a file name, whatever the name of your sound file is, however you're creating your sounds. Or maybe here we have another sound effect when the character dies. So we could say death. And we could say character loses a life. And maybe this is just a beep sound. So I could say beep. And then if I know the values for the sound, I could include that here if I want. Maybe it's beep 2, 10 or whatever. So you could put whatever information that you think is useful for your sound effects. Although, of course, you probably want to add that later, because right at this point, we're not going to be, again, designing sound effects or designing beeper effects or anything at this point. We're simply making a list of the effects that we will need. And similarly for the last section here that's titled music, we might want some music in our game perhaps. So we might want some music for the title screen, and maybe we want some music for the ending screen. Like that, and then we could just keep a list of all the different music we need. So there, now we have a list of the different elements that we need in our game, and we can obviously go back and add to this if we want. We can change it as we go along designing our game. So now, for example, I have user-defined graphics that I have 1 for the rat, I have maybe 3 for the cat, and then maybe the different items that the player will be collecting, maybe say item 1, and then item 2, item 3, and then maybe I need graphics for the walls of the maze, and maybe there's a few different wall patterns, so I might say wall 1, wall 2. So you can get an idea of what different elements you need as you think of your game and how you're going to design it. And just try and list all the elements you need on this assets page, and you can come back to it whenever you think of a new element. So maybe you think of a new element, that maybe there's a new graphic you need or a new sound effect you need, and we can always come back here later and add them to our list as we work on developing the outline for our game. So let's take a look at the next section here, which is called variables. So what variables might we need in our game? Well, as you can see here, first of all, I have different sections in my variable list. One section is called global variables, and another section is called local variables. Now, as I mentioned, I'm creating this game using BASIC, which doesn't use local and global variables. But how I'm using these names is the global variables will be variables that I'll be using throughout the entire program. So I would expect the entire program to be aware of these variables, which means I don't want to duplicate them. So these are global variables, as I'm calling them, which means I'm only going to be using them once. So I don't want to repeat these names in different parts of my program for different purposes. I can obviously repeat the names as long as it's being used for the same purpose. But for example, I might have a global variable called score, which is the purpose would be the player's score. And then I have an initial value section here. So the initial value of the player score would be, let's say, 0. And then I have a section for notes, which we can add any notes about these particular variables. So for example, maybe the player gets 10 points whenever they collect an object. And so I can just make a note of that. Player gets 10 points for collecting an object. And you can just go through and make a list of all the different variables you think you would need. And these are numeric variables, and you might have numeric variables and string variables, such as perhaps the user-defined graphics. You may or may not want to assign those to a variable. So for example, let's say we have 10 different items that I want my character to pick up as they're exploring the maze. And let's say I decided to add those items to a string variable so that I can change the pointer in that string to point to a different item as the game progresses. So maybe I'll have a string variable called aString, like that. And the purpose of the string variable will be to store the patterns for the different items. And the initial value will be a list of just 10 different items that are in my user-defined graphics list. So now I can go back to my assets page here. And you can see, well, where do my items graphics start? Well, my items graphics start here at character E, let's say. And then the next one is character F. So if my items start at character E and there's 10 of them, then I can put that on my variables list. E, F, G, H, I, J, K, L, M, N. So maybe I have a string that contains all the different user-defined graphics for 10 different objects in my game, and each object will be a single graphics character. For example, if I know that ahead of time, I can add it here, or I can add it later, and I can modify it if I need to. So now what are the local variables that I'm talking about? Well, these local variables would be, the way I'm using them, these would be variables that I want to be able to repeat in different sections of the game because they're only used in very small isolated sections of the code. And a good example of this in BASIC would be a for next loop. So obviously my game is probably going to have several different for next loops in it. And if those for next loops are contained in a small section of the code, then obviously I don't need to reserve a variable just for that for next loop. I can reuse that same variable for maybe all of my for next loops. So if I know that ahead of time, maybe I want to assign a particular variable for that purpose. So I might, let's say, assign the value x as my for next loop variable. So I'll just make a note of that. And then sometimes you might have nested for next loops where you have different variables that are active at the same time. And if that turns out to be the case, you can just come back here and add more variables to it. So maybe later I have a nested for next loop that uses an x as one of the variables, and maybe the next variable would be y, for example. And for this one, I'll put a purpose as a nested loop. So maybe my x variable will always be the outside loop counter, and my y variable might be the inside loop counter, for example. I can put a note about that here. Inside nested loop. Just like that. And then as we're going through the game and we're actually programming the game later on, which is actually the final step or close to the final step before we actually start testing the game, you see I'm not doing any coding yet. That comes much later. And then as you'll see later when we do actually code the game, then you could come back here and make a list of which module these particular local variables are used in. So let's say, for example, I have a for next loop in a module that I'm calling draw screen, for example. So I could enter the module name here as draw screen. And I like to make these bold and underlined so they're easily noticeable. So now we can easily go back and see where are these local variables being used in case we want to use them later, or we see a bug that this variable is not behaving the way we're expecting it to behave. Maybe we've reused that variable name by accident, for example. And you can see how useful this list will be to us later, because for example, you can see here I've used the variables x and y as local variables that get used in for next loops throughout the game perhaps, but x and y are also common variables that you might use as positional characters to keep track of a player's coordinates, their x coordinate and their y coordinate. So if you just sit down at the keyboard and start typing away a game we might easily get confused and start using x and y as the player's coordinate variables, or maybe as the cat's coordinate variables or the rat's coordinate variables, and then we might forget that we're actually using them in a for next loop. So that way it's good to have them on a list here ahead of time. So in particular, we want to try and fill up these global variables as much as we can at the beginning. So I'll just make some extra room for myself here. And we can think of what variables would we need this game to contain. And you might think, well, how do I know what variables the game is going to need to contain? But if we put some thought into it at this point, it will make it easier to create our game later. And we don't have to have a complete list at this point, but just a starting point is good enough. So let's see, what other variables might we need besides the score? Well, maybe the number of lives that the player has left. So maybe I'll have a variable called lives, which would be player lives remaining. Initial value maybe is 3. And then if you want to put a note, maybe the player gains an extra life whenever they complete a level. So here we've thought up a new feature for our game, and if we decide that that is a very important critical element that we want to have included in our game, we can go back and add that now to our feature list. So I'll go back to my overview and base features. I'll say player gains an extra life for completing a level. And so we can add extra features to our base features list if we really consider that a feature is so important that we want to make it a base feature. But of course we don't want to add too many base features, because they should just be the very critical features that we need in order to get our game completed initially. And we can always go back and add extra features later. So one question might be is, how and when do we decide if we're going to be adding extra features? And some possible answers to that could be, first of all, how difficult is it to add that extra feature? For example, if you have a feature that is very simple to implement, then you might be able to easily implement that. Even though it's an optional feature, if it's so simple to implement, then you could easily add that as a feature to your game later on, even though it's an optional feature. However, if a feature is very complicated to implement and is going to require a lot of coding, then maybe we don't want to add that feature right up front. We might want to hold off on that particular feature. And it also depends if your game is on a timeline. For example, if you want to have your game released by a particular date, let's say it's a themed game that is themed for Christmas or Easter or some other holiday, obviously you want to have your game finished by a certain date. Let's say you want to have your game done by December 1st if it's a Christmas game, so that people have a month to order it from you. So then we don't want to add too many features that are going to delay our game production. And so if we're on a timeline, that will also determine which extra features we're able to add, because we have to be able to finish our game on time, right? And another consideration that might determine when we can add some extra features is how we want to release our game. So we might want to release maybe different versions of our game. There might be, for example, a demo version of our game that just has a limited number of levels, or maybe there's a deluxe version of our game that has some bonus levels included, or maybe we decide to create a sequel to our game which will have different features and different elements, and so we're going to save those possible extra features for the sequel. So these are decisions we can make as we're developing our game and designing how we want to actually release our games. So at this point, all we want to do is concern ourselves with having a base list of features, and then any possible extra features we can add here as well. So now we've just decided that we want our player to gain an extra life every time they complete a level. So let's go back to our variables list here. And we can make a note about that here. Player gains an extra life when they complete a level. And if you want, you could make a note that says player loses a life when a cat touches them. Okay, so what other variables might we need in our game? Well, since the player is going to be moving throughout the maze, and let's say we've decided that our maze is going to be horizontal and vertical. It's going to have horizontal and vertical channels or pathways or corridors that the player can move in. And so maybe we want to have a way to keep track of which direction our player is moving. So maybe we have a directional variable that determines whether it's moving left or right, and maybe another directional variable that determines whether it's moving up or down. Maybe we have a variable called H direction for horizontal direction. And maybe we have another one called V direction for vertical direction. And the purpose would be to keep track of the player's vertical and horizontal directional movement. Player horizontal movement. Player vertical movement. And maybe the initial value is, it could be 0, or it could be maybe +1 or -1. So let's say the player starts off at a standstill. They don't have any movement at all, either horizontal or vertical, let's say. In that case, we might have this movement as 0 for both horizontal and vertical. And then maybe if the player moves one character position at a time in any particular direction, maybe their position increments by 1 or decrements by 1. So we could make a note of that too. We could say toggles between -1 and +1. For example, if you already know how you're going to be programming your game and you know that you're going to be using a value of 1 to make it move left or right, and you can always change this later as the game progresses as well, right? You might have this a variable number, or you might change the value of this number. And this will be the same, let's say, for the vertical direction, like that. And then we probably also need some variables to keep track of the player's position. And we need their vertical position and horizontal position, or their X and Y positions. So maybe I have a variable called X pos for X position, and Y pos for Y position. And I'll say player horizontal position, and player vertical position. And maybe we already have the map laid out. If we've already designed the map, like maybe we know that the player starts off at a position of 10, 14 on the screen. If that were true, then we could enter those values here, just like this. And if we don't know them at this point, let's say because we haven't designed the map yet, then we don't need to enter any values at this point yet, and we can add them later. And then we can put a note here, maybe indicating that these two different variables depend on the H direction and V direction variables. And then we might have some other variables in mind that we need to use in our game. So for example, we might have 3 cats. Each of them has an X and Y coordinate, for example. So maybe we can have variables indicating that for X cat 1, Y cat 1, X cat 2, Y cat 2. So cat 1 horizontal position, cat 1 vertical position. And then initial value, maybe they start off in certain positions. Maybe they start off, maybe cat 1 starts off in the top left corner. Maybe cat 2 starts off in the top right corner. So we could put different values for that. Maybe 1 and 1. And then maybe the other one is, I don't know, 10 and 1. So then if we know the initial values, we can enter them here or come back and add them later. So what we want to do is essentially add as many of these global variables as we can think of at the beginning of our game, and that will help us greatly in actually coding our game later. So now let's take a look at the final section, which is called modules/flow. So here's where we list the different subroutines or modules that our game will contain. And my game will contain generally a main subroutine or a main program loop, which doesn't contain much code at all. It should contain a minimal amount of code because the main purpose of the main program loop is to call other subroutines. And most of the work of the program gets done in the subroutines, not in the main program loop. So here I have some headings that say subroutine name, purpose, pseudocode, and code. So what will my subroutine name be? Well, since this is going to be my main program loop, I'll just call it main. And I'm going to use bold and underline so it's easy to spot. Just like that, so my main program loop will be called main. So I'm just going to describe it as main program loop. And then here you can see I have a section or a column called Pseudocode. So what do I mean by this? Well, you might be familiar with games that are flowcharted in order to diagram how the program flows through the different modules and how it branches and how it moves from one part of the program to another. And you can flowchart a game like that using a graphical flowchart with boxes and lines and arrows. However, in this method, I'm using a list form of flowcharting, which doesn't require the graphics. And I actually find this more useful because I can actually use it to enter the code later when I'm programming the game. So let's see how this works. So in my pseudocode column here, and if you're not familiar with pseudocode, pseudocode is just really an English description of the programming code. So instead of having to know the syntax of the code and knowing what commands we need to accomplish certain tasks up front, we just write an English description of what we want the program to do. So in this case, the first thing I want the program to do is, let's say I wanted to initialize the variables. And in order to initialize the variables, I'm going to have it call a subroutine. And let's say I'm going to call that subroutine init, which I've already got listed down here in my second subroutine section right here, init, and we'll take a look at that in a moment. So let's say I already know ahead of time that I have a subroutine called init, which is where I'm going to be initializing the variables. So I want to call that subroutine now, right? But since this is a basic program, my program doesn't know where init lives. It doesn't know which line number init is at, because init is the subroutine that's going to initialize all the other line numbers for all the other subroutines. But of course, my program doesn't know where that subroutine init lives yet. So I'm going to tell it right now where it lives. And if we take a look down, I've made a note here that init is going to begin at line number 8000. So here, what I want to do is assign a value to a variable which indicates where this init subroutine lives. And it lives at line number 8000. So I'm going to assign a variable called init, and I'm going to give it a value of 8000. But before we do that, I'm just going to describe that in pseudocode or in English rather than actually entering programming commands. So I'm just going to say assign line number value to init variable. And I'll put a checkbox here. And then I want my program to actually call this subroutine so that it can assign the other values and variables in my program. So I'll put another entry here called call init. And I'll make it bold and underlined to show that it's a subroutine. Like that. There, so this first part of my program, I wanted to do these two tasks. I wanted to assign a line number value to a variable called init, and then I wanted to call that subroutine called init. And if I happen to know the code for performing these tasks, I could enter it right here in the last column, labeled code right now if I wanted to. But normally we would come back later and fill in this code column later after we've entered all of the subroutines. But since this one is so easy, I'm just going to enter the code right now since I know it offhand. So obviously assigning a value to a variable is very easy. And I know that value is going to be 8000 because the line number for my init subroutine is going to be 8000. So I'll just simply say let init equal 8000. And then the second thing I want to do is call that subroutine. And how do I call a subroutine in BASIC? Well, of course, I use the gosub command. So I'll just type gosub init, because now I've already assigned a value to this variable called init. I don't need to put a line number in my gosub instruction because I've assigned it obviously a variable called init. So instead of saying gosub 8000, I can now say gosub init. And I'll make that bold and underlined as well. Just like that. So now this is the code that I need for this section of my program. Now before we go any further in our program module workflow, let's take a look at that init subroutine and try and figure out what we need to initialize. So if we go down here to our init subroutine, our init section of the program, the purpose of the init subroutine is to initialize the variables. So I'll type that here. And then what actions do I want it to take? In this case, I know this particular section of code is going to assign values to all the variables. So I'll just make a note about that. Assign values to variables. And now in this final column here, the code section, if I already know the code that I want to enter into this section, I can do it right now, or I can wait till later. But do I already know what code I want to put in this section? Well, since this section is going to assign values to variables, I can at least get a head start on it, because remember, we just made a list of all the variables that our game will include right here, right? So now I could take these variables and I can actually assign the code for them over in our modules. So I have all these different variables, score, lives, so forth. So I can say, let score equal, let's say 0, let lives equal 3. And then if I want to, I can continue and define all the rest of my variables, or I can wait and finish them off later. So at least now this is a starting point for our variable initialization routine, and I can continue on with this, assigning all the rest of the variables, or I can leave it for later. Now at this point you might be wondering, since we're typing in our basic program into this Microsoft OneNote or Excel or Word or whatever you're using to enter in this workflow listing that I'm sharing with you, you might be thinking, how are we going to get our basic program into a computer or into an emulator? How are we actually going to run this program? And another question you might have is, shouldn't we be typing this into a computer initially up front so we can play around with it and test it and make sure we got our code working and everything is fine before we make a note of it as a text file? Like, doesn't it seem like we're doing it backwards? Well, actually, we should already have an idea how we're going to be entering the programming instructions to accomplish these tasks. Like, for example, we should have an idea how to assign variables and how to print stuff on the screen. We should already have an idea of what instructions we need to accomplish those tasks. However, if we do want to test out a piece of code ahead of time, we can do that now before entering it into our code notes, or while we're entering it into our code notes. So you could have your computer turned on, or if you like, you could use an emulator. And then if you're entering a piece of code and you're not really sure about it, so for example, let's say I bring over my CSpec emulator here. I can just test it out here while I'm going along. And maybe I'm not sure what type of variables I can use in a for next loop, for example. So I can try that out. For example, I might know that I can use a single character in a for next loop. So I could say 100 for a equals 1 to 5, like that. And I see the computer accepts that. And maybe I want to use a variable name called apple, right? So let's see if that works in a for next loop. I could say line 200 for apple equals 1 to 7. But now we can see the computer doesn't like that, so I know I can't use a multi-character variable in a for next loop. So I can go ahead and test out parts of my code either in my emulator or on a computer as I'm going along and typing them, but I'm not actually typing in my entire program in the computer or in the emulator up front. I'm just testing certain modules of my code, or even certain parts of the modules, so that I know exactly what I need to put in my workflow. And remember, the code that we're entering into our workflow doesn't need to be perfect right from the get-go, because we're obviously going to be testing this later, module by module ideally, and seeing which parts of it work and which part don't and which part needs adjustments. So this is just a starting point, but it allows us to organize our program in a way that will make it very easy to create and test later when we're actually doing the coding. Now, to answer the other question of how do we get our text program here into the computer, well, obviously one way would be to retype this code into either an emulator or the computer, but of course that's not what we're going to be doing. Well, what I'm going to be doing in my workflow is I'm going to be using the information that we covered in last week's video, which is where I described how to set up a basic development environment, which allows us to convert text files into basic programs, and then those basic programs can be run in our emulator or on a real computer. So this way, all we need to do when we get to that stage is to simply copy and paste our text into a text file, and then we run that in an emulator or on the computer, and we'll be seeing exactly how that works a bit later. But for now, let's go back to our game development workflow here and see what other subroutines we might need. So far, what we've done is we've called a subroutine called init that we know assigns initial values to variables. So once the initial variables are set up, then what else might our program need to do? Well, in this main program loop, we want to try and restrict this loop to just calling other subroutines and executing as little code in this main program loop as possible. So what other subroutines might we need to call? Well, maybe we want to call a subroutine to print a welcome screen. So we can go down and fill out this purpose column with what we want our program to do. So maybe we want to print a welcome screen. And the way we're going to do that is by calling a subroutine, and maybe I'll call the subroutine welcome. Just like that. And then what else might we want to do in our program? So after we've printed a welcome screen, maybe we want to give the player some options to either start the game or exit the game, or maybe redefine the keys or select a joystick or keyboard or whatnot. So we can make a description about that as well. We can say maybe get player input to start the game. And maybe we'll call that subroutine input 1, and we'll call it here. And now here we have a choice depending on what we want the player to be able to do. So now we can take a look at how we can use this form of kind of list flowcharting instead of graphical flowcharting, because the input screen might allow the player to make several choices, for example. So let's go down and create some sections for these subroutines that we're going to be calling. So first of all, let's create a subroutine called welcome. And I like to keep the subroutines in alphabetical order. So I'm going to put the welcome subroutine down here after init, because W comes after I. So I'll put a subroutine here called welcome. And the purpose of this is to print a welcome message. So what actions might we perform in the welcome subroutine? Well, first of all, it's going to print a welcome message. And maybe it's also going to prompt the player for an input, maybe to change the keyboard or to start the game or exit the game. So I'll say prompt player for input. And then I won't bother putting the code for that subroutine in just yet. I can do that later. But now I'm going to go back up to my main program loop and see what our other subroutine is. Here it's called input 1. So let's create a subroutine called input 1, and we'll put that in order as well. So where would that go? So that would go here between init and welcome in alphabetical order. So I'll put that right here. Input 1. And what's the purpose of this subroutine? What type of input is it going to get? Well, let's just put a general purpose of get player input. So now in this section of the code, the player is going to have an option to select one of several different choices, right? So since they have a choice and the program is going to be branching, I'm going to enter a grid here that outlines all the different choices or the different possible branches. So they can either start the game, exit the game, redefine the keyboard, or select the joystick. I'll just make a grid with those 4 options. So I'm going to insert a table here that has 4 options. The first one will be start game. The next one will be exit game. The next one will be redefine keys. And finally, the last one will be select joystick. And then in these branching kind of tables, this is where we determine how the game flows. So let's say if the player starts the game, maybe I just wanted to return back to the main program loop that called it. So here I'm going to say return. And I like to put that in bold and in red, so it's obvious where the return statements are. So if the player chooses to start the game immediately, it's just going to return back to the main program loop. And of course I can decide how I want my game to branch. And so let's see what the next option here is, exit game. So if the player chooses to exit the game, Well, we could do a few things depending how you program your game. We could maybe set a flag that tells the main program loop the player wants to exit, or maybe I can just immediately go to a subroutine that exits the game. Since there won't be any more program execution, it's just going to end there and die there. Maybe I'll just have an exit subroutine that I can call directly from here. But I'm not going to actually call it by go subbing it, because I'm not expecting it to return because the game is over. I'm going to just go there with a goto statement. So I'll just say go to exit. Just like that. So we know it's going to go to a subroutine and it's not going to return from that subroutine. And now I want to create a subroutine called exit. So I'll put that up here in alphabetical order again. So here we have a subroutine called exit, and the purpose is to end the game. Just like that. And what actions will this subroutine take? Well, maybe I want it to clear the screen. And then maybe I want it to print a goodbye message. And then maybe I want it to stop the game, stop the program execution. Just like that. So those are the three tasks I want this subroutine to perform. And of course I'm going to come back later and actually enter the code to perform all these tasks. And now let's go back to our little grid here where the player is making an input selection and see what our next choice would be. So now he's going to redefine the keys. So what happens if they choose to redefine the keys? Well, I think at this point I would call a subroutine that redefines the keys. So here I'm going to use a goSub statement because I'm calling a subroutine that I expect to return from. So now I just need to name that subroutine. Maybe I'll call it keys. So now the program will call a subroutine that is called keys. But remember, since the program is going to be returning from this subroutine back to this part of the program, then what's going to happen once it returns? Well, once it returns, let's say I want it to return back to my main program loop. So I better indicate that here as well, right here. Just like that. And I'll make it bold and red because it's a return statement, which I like to have bold and red. And so now it should go sub a subroutine called keys to allow the player to redefine the keys, and then it returns back to my main program loop. So now we better include a subroutine called keys. And where would that go? So that should go in between E for exit and I for init. So I'll just enter another line here and I'll put a subroutine called keys. Just like that. And what's it's going to do? It's going to redefine the keys. And what actions will it do? So now we can list the different actions if we know the specific actions of how we're going to redefine the keys. So maybe we clear the screen. Maybe we print a message. Maybe we get player input for keys. And then we can just continue adding the rest of the pseudocode that we would want this subroutine to perform. And then once it comes back from this subroutine, we need a return statement. So we better put a return statement at the end of this subroutine right here. Just like that. So that we know this subroutine is actually going to return to wherever it called it. Now remember, this exit subroutine is not returning because the program is going to end in this subroutine. It's going to stop execution. So we don't need a return instruction in this exit subroutine, for example, but we do need one in this keys subroutine. And you can see here, we can take a look at any subroutines that are missing a return statement that should contain a return statement. For example, this init subroutine, that one should have a return statement because we're calling that from our main program loop right here, right? So obviously we want the program to return from that subroutine, so we better put a return statement there, just like that. And let's see, we have a welcome subroutine here, so that one should return at some point, so I better do the same thing for this one, like that. All right, so now what do we do? Well, we see we have another selection here for select joystick that we need to put some pseudocode. And what's going to happen when the player wants to select the joystick? Well, maybe we want to call another subroutine to enable the joystick. So here we'll say go sub joystick. And then we need a subroutine called joystick, which I'll put right here in alphabetical order again. And before I fill in some details for the joystick, I'm just going to go back here and put a return statement. Right there. And now we might want to fill in some details for the joystick subroutine. It's going to enable the joystick. And then whatever pseudocode it needs to perform that task, maybe turn on joystick port or however it works. And then it's going to have to return from this subroutine as well, so I need my return statement. Right there. And this is how we create our program flow. We just keep going along and we enter these different subroutines. And now you can see we have our main program loop that's calling our subroutines, and we have our subroutines that are performing certain tasks. And we just keep going along and filling out these different sections. And then once we've got all these filled in, we go back and we actually enter the code for the sections. So let's say we finished entering all the information for our subroutines and our main program loop and the pseudocode for indicating what's going to take place in all the subroutines, and we've outlined how the program will flow using these little entry grids that we've put in our return statements and our go-sub and go-to statements. Now we can go back and enter all the actual code that we need to perform these tasks. And it's probably best to do this kind of in order of the way the program actually flows. And we want to make sure that all the tasks in the pseudocode column have checkboxes so we can check them off after we've entered the actual code that performs those tasks, right? So here I've got my checkboxes now, and all of my pseudocode needs checkboxes. So here I'll put checkboxes as well. And every checkbox indicates some piece of code that needs to accompany this instruction. So here if we start at the top, our first instruction says assign line number value to init variable, which we've already done right here. Let init equal 8,000. So we can check this off. Then the next instruction says call init. And here we have an instruction that says go sub init. So that's done. What's our next instruction? Next we want to call a subroutine called welcome. So we just enter the code for that, which is going to be a go sub statement. And the name of the subroutine is called welcome. Just like that. And we can check that one off. The next one calls a subroutine called input. So we do the same thing for that one. Go sub input. Just like that. And then we check that one off. And now we can go through and fill in the code for all our subroutines. And these we can do in whatever order we feel comfortable, whatever makes most sense to us. If you want, you can go from the top down, or you can try to follow the program flow and enter the code according to the program flow if you like. But let's say I just start from the top here and I want to enter the code for this exit subroutine. Well, the first task says clear the screen. Well, how do I clear the screen in BASIC? Well, I'm going to enter the clear screen command just like that, and I can check that off. The next instruction says print goodbye message. So maybe I'm going to print at whatever location 10, 5, and here's where you would play around on the actual computer or in an emulator to see where exactly you want to print this message and what messages you want to print. So maybe I'll say print at 10:5, goodbye, thanks for playing. And I don't know if that actually fits on the screen or not, but again, I'd be playing around with that in my emulator or my computer. So I've printed my goodbye message. And now what's next? I want to stop program execution. So maybe I'll decide to do that with just a simple stop instruction. Just like that. And I can check this off. And now the code for my exit subroutine is complete. And you can see I haven't actually typed a single line of code into an actual computer or an emulator at this point. But I could do that if I want to test the code before I enter it into these subroutines. And I just keep going along and entering actual program instruction code now for all of the different subroutines that are included in my game. And now we're going to take a look at one feature of this programming method that actually kind of makes it easier for us when creating basic programs, because of course basic programs use line numbers, which can be a pain to work with, but actually using this workflow makes it a lot simpler to work with. And the way we do that is like this. So once we have all of our modules defined, we can see how many modules we have, and then we can decide how many line numbers we need to assign to each module. So let's pretend that this program is complete now, and we want to start entering line numbers for our code. So let's see, how many sections do we have? Well, here I have one section called main, which is my main program loop, and it's divided up into a few sections. Now, you'll notice that some of these sections don't have subroutine names next to them because they're not going to be called as subroutines. This is part of the main program loop. These are just different tasks that the main loop is performing, although if we ever needed to call these sections, we could assign them names if we want to. For example, let's say we have another part of our main program loop where the actual game begins. Let's say we'll describe the purpose of this section as begin the game. Just like that. And so maybe this section we call over and over again whenever the player loses a life or something like that. So we don't want to go back and initialize all the variables and print the welcome screen every time the player loses a life, for example. So this particular task, we may want to assign a subroutine name to it. Although it's not a subroutine, we can still assign it a name. Let's just call this game. Just like that. So now if we do want to refer to this particular part of the code, then we can easily call it by its name. And we have to remember to make sure that all of our subroutine names get assigned in our variable initialization subroutine. So for example, this main name, this game name, and all of these names here, exit, keys, init, all of these subroutine names need to get assigned line number values to them, which we're going to do in a moment after we actually assign line numbers to them. So how do we assign line numbers to all of our code in our game now? Well, since we've divided it up into different subroutines or different modules, it's quite easy to assign line numbers now because, as I mentioned, all we need to do is figure out how many line numbers we want to assign to each section in our game and where they're going to begin. So let's say I want my main game loop to begin at line 100, and I'll just enter that here, line 100, and then maybe our game loop here, I'll have that begin at line 200, just like that. So that gives me 100 lines to work with in my main program loop, even before it gets to this game program loop. And now since we've got our program split up into such small subroutines, we don't need to save space with a bunch of extra lines. We could just have these lines numbered sequentially one after the other, or maybe separated by 2, because it's very easy to renumber them later because there's so little code in between them. For example, if we start here, let's say at line 100, and then the next line, maybe we'll make that 102, and then the next one maybe is 104, maybe the next one is 106. So you see we have a lot of line numbers to play with because we know exactly how many lines of code we need to assign line numbers to, and we just leave ourselves a bit of extra space, and we can always renumber later. Let's say we need to renumber these lines of code here from 100 to 106. Well, there's only 4 lines of code, so it's very easy to renumber them if we have to. And similarly for our subroutines, we do exactly the same thing. Let's say we want the exit subroutine to begin at line 1000. And it doesn't matter where these subroutines live, what line numbers they begin at, because they're subroutines. They're just going to be called, execute some function, and then they're going to return. So let's say I have the exit subroutine beginning at line 1000. And then maybe I want to separate each subroutine by 100 lines. So that will give me a lot of different subroutines I can work with if each one only contains 100 lines. 100 lines will give us 10 subroutines for every 1,000 lines. And since a basic program can contain up to 10,000 lines or 9,999 lines, so if we have 10,000 lines to work with and each subroutine takes up 100 lines, then we could have 100 subroutines. So we just keep track of how many subroutines we have and how many program lines of code we want to assign to each subroutine. Some subroutines might be very long, some subroutines might be very short, and we can just decide how many program lines we want to assign to each subroutine. But again, it doesn't matter where those subroutines start and stop as far as the line numbering goes, so we can just go ahead and assign them now in order that the subroutines are laid out in our program. So for example, my next subroutine here is called keys, and maybe that starts at line number 1100. And then our init subroutine here is already identified as starting at line 8000, so we'll leave that as is. And then our input 1 subroutine here Maybe that one will go back and start at line 1200. And we can just go down and do that for all our remaining subroutines. 1300 for joystick, 1400 for welcome, just like that. And then after we've done that, we can go back and assign line numbers to the actual code. And these line numbers can be spaced very tightly if we want. So here in our exit subroutine, which starts at line 1000, I'll just enter 1000, and then 1002, then 1004, and there, our code for our exit subroutine is complete, including line numbers. So we just keep going through and now add all the line numbers for all of our code. And obviously I haven't filled in all the rest of my code in this example yet, but that's how we would do it. And now let's go on to the next step of how we would actually get this code in text form into a program in basic form. So in my example, I'm going to be using the Visual Studio Code editor, which is right here. And I'll start a new file. And since I have the Next Basic extension installed in my Visual Studio Code editor, I should get syntax highlighting when I go up here and select language as Next Basic. And if you're not familiar with this already, you can go back and watch the previous video where I showed how to set up this development environment for creating Next Basic programs. And this will allow us to now get syntax highlighting for my basic program. Alright, so here I am in my Visual Studio Code editor, and the first thing I want to do is save my program as we saw in our last video under the name myproject.txt because we want to save it as a text file, just like that. So now you can see it's called project.txt because we need it to be called project.txt in order for our configuration routines to be able to convert it to a basic program. And now what do? Well, now the fun part starts because we go back to our notes and then we simply copy and paste the different lines of code from our subroutines. So for example, I might go here and copy the code from my main program loop right here, and I'll paste it into Visual Studio Code just like that, and clean it up. If it has extra blank lines or whatnot, then I can clean it up. So there you can see I have my code now easily copied into my Visual Studio Code editor. And now if I save my program as project.txt, then I can convert it later into a basic program very simply. So that is the program flow that we would use for actually creating the program. And now I'm going to show you a program that I actually created using this method. And this is a version of a breakout program that I've called Bricks. And I'm going to show you that in just a moment as a teaser. But before we get to that, let's just take a quick peek at the rest of the steps in my program flow development environment. So I'll go back here and we'll take a look at my dev list. So now if you're going through this workflow in the way that I've described it, and you take a look back at this dev list section here, and we can go through the checklist and see what parts we've already checked off. So the first step is the overview, where we put the description, the gameplay, the features, and so forth. So we've done that right here in our overview, remember? So we can go ahead and check that off. And then we created a list of assets, which is all the artwork, graphics, sound effects, and so forth. We can check that off. And of course we can update these different sections and modify them and add to them and change them as we're going through and creating our modules and testing out the different pieces of code either in an emulator or on the computer. And so we finished updating our list of assets and we check off this step. And then of course we have our list of variables that we'll complete in a similar fashion as we go through creating our program modules. And we'll check that off. And then next is flow, modules, and pseudocode, which of course is this module section we just took a look at. So once that's all complete and we've listed all of our modules with all of our pseudocode, we can go ahead and check that off right here. And then let's just take a look at the rest of these steps. So this one says create asset placeholders if needed. So that would be things like dummy graphics. For example, remember I mentioned we don't want to create the actual graphics and spend a long time creating the real final version of our graphics because that's very time consuming. For now we can just create placeholders for the graphics like letters or any kind of simple graphics that will work for our purposes just to test the game and its mechanics. So let's pretend that we've gone through and created the graphics for our games or the graphics placeholders for our games, and we'll check that off. Then the next thing it says is to code the modules. So this is where we complete the step that we were just looking at over here, where we entered the actual lines of code into our game. And in order to be able to test some portions of our game or some modules, we may need placeholder graphics already created in order to do that, which is why we have the step for creating those placeholders above the step for creating the code to test our program. So let's say we now entered and tested all the code for our modules. We can go ahead and check this off. And now the rest of the steps in this task list is basically testing and refining our program. So for example, here I have an alpha testing phase, which is where the program is complete, but we need to do an initial test. That's the alpha testing. And then the next step here would be to fix any bugs that we find in our initial testing and make any necessary modifications. So we can check that off. And then here we have finally a step that says create assets. So once we have our initial testing done and we know that our game is working, the mechanics are working, and we have all the features we want, at least for our initial version of our game. So after that, we know it's just a matter of refining it even further and removing any remaining bugs. At this point, we might want to go ahead and create the final assets for our game. The graphics, the sound, the artwork, the pixel art, the sprites, the tiles, any actual assets that we need for our game. Now would be a good time to go ahead and start working on those final versions of our assets. And then we can go ahead and check off that step. And then once we have the final graphics and assets and everything ready, then we can start our beta testing phase, where we can distribute the game to a limited number of game testers, and they can test the game for us and give us their input. And so that beta testing will identify maybe some modifications we might want to make either to the gameplay or the mechanics, or some bugs that get highlighted, so we can go ahead and fix those things and check this off. And then once we have our game actually finished testing and we think that it's perfect, we do one final round of testing. And if we want, we can just complete the beta testing phase over and over again until our game is bug-free, or as close to bug-free as possible, or until we run out of time and we have to actually release our game for some reason. And then the final step is exactly that, which is upload and promotion. So however we choose to release our game, whether it's on a website or we're advertising it in a Facebook group, or whether we're making a physical copy available, or whether we have maybe a distributor, however we're going to actually release our game, that would be the final step, is to upload our game to whatever platform people are going to be using to purchase it. And then we promote our game by making whatever advertisements we choose to make, and then we're done. So that is just a quick look at the rest of the steps, which is pretty self-explanatory. So now let's go back and take a look at my game, and we'll see how I've used my workflow to create my actual game. So my game, as I mentioned, is a breakout style game, and it's for really the Sinclair Spectrum computers. It's not using really any advanced features of the ZX Spectrum Next computer, but I'm going to be designing it to run on the ZX Spectrum Next, although it will just be using basic simple features. So here's the overview for my game, and I'm just calling my game Bricks with a Z and an exclamation mark. And the description says, Bricks is a fast-paced arcade game for one player to try to achieve as high a score as possible by dismantling a wall of bricks using a bat and a ball. So very complete, very self-explanatory, and very precise, very concise description of my game. And let's take a look at the gameplay now. It says the player uses the keyboard to control a paddle that moves left and right along the bottom of the screen to deflect a bouncing ball into the wall of bricks positioned at the top of the screen, earning points for every brick knocked out. And now let's take a look at the basic features that I've decided I want to include in my game. And here it says there are 7 rows of random colored bricks. Special power bricks are distributed randomly throughout the wall of bricks. Player starts with 1 active paddle plus 3 extras. Highest score displayed on screen during gameplay. So the highest score will be displayed on the screen all the time while the game is being played, as well as the current score is going to be displayed on the screen while the player is playing. The number of remaining paddles is also going to be displayed on the screen. The level number will be displayed on the screen as well. An extra paddle will be earned for every screen that the player clears. The player earns 1 point for every brick knocked out, plus bonus based on ball color. So how this is going to work is, well, we'll just take a look at the next line here that says ball color changes to next higher color every time it hits a special power brick. So these power bricks are going to be distributed throughout the regular bricks, and every time the ball hits one of those power bricks, the color of the ball will change to indicate a bonus multiplier or a bonus addition that gets added to your score. So from then on, every regular brick you hit earns the player a score of 1 plus a bonus. And every time the player hits another bonus brick without losing a life, then the color continues to increment to the next higher color, and the bonus also continues to increment so that the player earns more points depending on the color of the ball. And then some other features say hitting a power brick awards 10 times current score plus the bonus. So the power brick itself will award an extra score 10 times the current value of the score plus the bonus, and then it will increment the bonus level. And then the bonus value and the ball color changes reverts back to the lowest level when the player misses the ball. So these bonus levels that increment, they drop back down to 0 if the player misses the ball. And let's see what else we have. Finally, the ball changes color to indicate points multiplier. And the ball color points multipliers are according to this chart here. So if the ball is black, the player earns no extra bonus points. If it's blue, they earn 1 extra bonus point. And if it's red, they earn 2 extra bonus points, and so forth. So these are the various base features that I want my game to contain. And I also have a small list of possible extra features here, as you can see, that maybe the ball reverses direction if it hits the edge of a paddle on the end it's approaching from. So right now when the ball hits the paddle, it'll just continue on in the same horizontal direction. But if I want it to change directions, maybe if it hits the corner, then I might implement that feature. And then there's a few other features here. Ball speed increases with every level cleared, perhaps. Additional power brick types that have other special effects. And maybe I'll have the paddle size be variable, so it changes size based on certain things that happen in the game. So those are possible extra features I might add in a later version of the game, or if I have time to add them to this version of the game. But those are not critical features that I need to have included in the game for it to be considered to be complete, but they're just possible extra features I might add at some future time. Alright, so if we take a look here at the game outline that I've created for my game called Bricks, which is a breakout style game, as we just discussed, these are the different modules or subroutines that I've included in my game. And if we take just a quick scan through this listing, you can see it's fairly long, but not really that long. Actually, the longest section in this game is the initialization section, where we set up all of the variables. Because if we take a look at the variables list for my game, that is quite long. There are quite a number of variables in this game, as you can see here, and they're all listed. Let me zoom in a bit so we can actually see them. So here you can see the variables in my game. These are my global variables, which, remember, these are variables that I'm only going to be using once in my game or for one purpose in my game. I'm not going to be reusing these variable names for different purposes. So they won't be used, for example, in a for next loop. But these are all the variables that I have in my game, and they have even variables for the beeper sound duration, the beeper sound pitch. So I'm using variables to control some sounds in my game. And so those are those variables. And here I have a few string variables that I'm using. And then I have some local variables. And you can see how I've used the local variables. For example, I have this one called brick offset, one called brick pattern, brick type, and then just some single letter variables. And I've indicated here what their purpose is. So here's a Y position adjuster for when erasing a brick when it's hit, an element identifier for brick patterns, and so forth. And so all these variables that I only use once or for one specific purpose in one very limited area or section of my program code, then those are what I'm calling local variables, because if I want to, I can repeat these variable names for use in different sections of my code if I want to. And so I keep a record here of which sections of my code or which subroutines those particular local variables are being used in. And here I just list all the different subroutines with their names right here, and I have some notes of how they work. So if I go back to my actual game module listing now, which is right here, and I'll zoom in this one a bit as well, so we can see these are all the modules that I have in my game, and they're all listed in order. Ball erase here, ball position calc, ball position check, and it shows the different line numbers where they start. And if I scroll over to the code section here, we can see that some of them have the line numbers already indicated and some don't. Alright, so now that we have our workflow completed and our game template all filled out and our game details all filled out, including the code and line numbers and everything, and we're all ready to go and actually create a basic program out of this and start testing the different modules and the different sections. Let's see how we would actually go about doing that using our new game development environment that we set up in our last video, and we'll see how we can actually accomplish this to get our game actually tested and completed and finished. So let's take a look. And now what I can do is I can go through and test the different sections of my code one at a time in the order that they're going to be used in the game. So it's up to you how you want to test your code sections. Obviously, each section of code that you want to test needs to have all of the supporting information already created for that section of code, for that subroutine. So any variables that it uses, any other subroutines that it calls, those also need to be set up ahead of time if you're going to actually be testing that functionality. But let's take a look at an example from my game. And if we go to the main program loop here, right here, so you can see these are all the instructions for my main program loop. This top section here is my main program loop, and here are all the instructions for my main program loop here. They start at line 90 and they go to line 310. So if I want to test this out now, what I can do is copy all this code right here, and I'll just paste it over this code here. So here's the actual code for my game, and we can see what it does. So here we have a ren statement, and then we have some variable assignments, and then we have a section of code that calls a bunch of subroutines. So let's say I wanted to test out my game now. What I'm actually going to do is rem out some of these lines of code because I don't want to test all of these subroutines at once. I want to test them one at a time, just the ones that are ready to be tested or the ones that I'm interested in testing. So let's say, for example, I just want to test out this init subroutine. So I'm going to comment out all the rest of these lines of code by just putting a semicolon at the beginning of the actual instruction, just like that. And I'll do this for all of them. There. So normally you won't have to do this when you're testing a subroutine, but since this is my main program loop and its entire purpose in life is to call a bunch of other subroutines, I'm going to have to comment out the different subroutines that I'm not testing at this point. So let's see what this part of my code is going to do. So here at line 91, it's going to set a value of 100 to this variable called high score, which is fine. It doesn't need to call any subroutines to accomplish that. And then it's going to set a string value to a string variable called nstring, which is fine. And then it's going to let init equal 8000, which is going to set a value which is a line number 8000 to this variable called init, which is going to represent the init subroutine. So let's go ahead and just test this part of my program first, just to see if this works. So now in order to test my code and execute it in the emulator, I need to first make sure that it's saved as the text file called myproject.txt, and it's actually saved as project.txt. So I need to resave this as myproject.txt. So I'm going to click File, Save As, and save it as myproject.txt. So now it's saved as myproject.txt because that's the name it needs in order for the batch files that I discussed in my previous video to be able to work properly. And so now in order to convert this program into a basic program, as I showed in my previous video, the way I'm going to do that is by executing a batch file, and the name of my batch file is called build. So I didn't describe this part in my last video, but what I've done is I've actually combined the 3 batch files that I did describe in my last video into one. So I've created a new batch file called build.bat or .bat, and it will basically execute all 3 of those batch files at once. And if you want to see it, I can just show you my batch file right here. Alright, so here's my batch file, and you can see all it does is execute 3 other batch files, one called text to basic, which converts our text program or our text file into a basic program, and then it calls monkey.bat, which injects our basic program into the ROM image for the cspect emulator to be able to find, and then it runs cspect.bat. And now if I type build, it should execute those 3 batch files using my new combined batch file, and it should automatically convert this text file into a basic program and then inject that basic program into the ROM image for the cspect emulator to use, and then it should finally open the cspect emulator. So let's go ahead and type build and give that all a try. So there, it's converted the program into basic, and now it's opening the cspect emulator, and I should be able to navigate to the program now, which is right down at the bottom here, called myproject.bas. And now when I press the enter key, I believe it should automatically execute this program for us. So let's give it a try. All right, so it looks like it did execute, and I'm just going to bring up the listing, which is right here. You can see this listing should match my basic program right here. And you can see it does. I have line 90 is a rem statement, and then line 91, line 92, let high score equal 100, let end string equal Sir Sprite. So my program has been converted properly, and it's been injected into the ROM image, and it's now showing up here in my cspect emulator. And so it did execute properly, but it didn't show any output on the screen because this program, the way it's currently set up, is not designed to print anything on the screen. All it's doing is assigning a few values. So if we go ahead and run it manually now, then we can see it just gives us the OK message. And so far it looks like our main program loop is working and doing what it's supposed to do. And remember, we've commented out most of these go-sub statements, so all it's doing is a very limited part of this main program loop now. So let's go ahead and add some more code to it and test that out. So the next thing I want to add to it is my init subroutine right here, which begins at line 8000. So I'm just going to go ahead and copy and paste all this code here. You can see I've added line numbers beginning at line 8000 here, where I'm assigning values to all of these variables all the way down here to my final return statement at line 8999. So I'm just going to go ahead and copy all this code, and now I'll go ahead and paste it into our Visual Studio Code editor. And since it begins at line 8000, I want to paste it after line 310 here, because 8000 obviously is higher than line 310. So I need to paste these lines of code in the correct location where they would normally appear in the basic listing. So I'll just go ahead and paste it in here. And there we go. All my assignment statements are here. And so this is my init subroutine, which gets assigned up here. So here we're assigning a value of 8000 to a variable called init. 8000 is the line number where my initialize subroutine begins. So now let's re-enable this go-sub instruction that actually calls this subroutine to initialize all those variables, and we'll test that out. So I'll just remove this semicolon here, and now this go-sub statement is active. It's going to actually call this subroutine by executing this go-sub init command right here. But now, since I have more code attached to this program, I just want to put a stop statement at the end of this main program loop so it doesn't just run into the rest of my code. So just temporarily I'm going to put a stop statement here, and let's say line 311, because that's the end of my main program loop, and let's enter stop here just temporarily so I can do my testing. And now I need to resave this program as my project.txt, so I'll save it now. So now it's saved, and if I go back to my command window now and I type build again, it should reconvert this new version of my program, and we'll see what happens. So there it's opening the cspect emulator, and now if I navigate to my program again, which is down at the bottom here, myproject.bas, you can see it's showing a stop statement here now at line 311. So it looks like it did actually execute our code, and it hit the stop statement at line 311. And if I press enter to show the listing, it should now show all of our new code that we just added to our listing. And here it is right here in the 8000s. All these variables are being assigned. And we can go ahead and do that for all the rest of the sections of our program. We can simply copy and paste all the code from the different subroutines right here. So let's say we have another subroutine we want to test. We can just add line numbers to it. And how this makes it easier for us is that now, before we even type our first line of code, we have basically our entire program listed out here for us, and we can easily go back and modify it and change it and test different pieces and debug it module by module. And if we need to renumber a section of code, we need to renumber a subroutine, we can easily do that because the subroutine contains a smaller number of lines, and we've already organized our subroutines into different sections, so we know how many line numbers we've assigned for each subroutine, and we have all the space allocated properly in an organized form that makes it easy for us to work on. Alright, so let's test out one final thing here. I'm just going to copy one final subroutine into my editor, and we'll go ahead and test that out. And this is one subroutine that I've actually done just a bit of work on. It's the main welcome screen. So I did a little bit of design work on this one. It's very simple, but still this one should be ready to go. And if you look here, I'm going to be using this subroutine here, which is called welcome. And I'm going to be copying this code for the subroutine, which is right here. You can see I've given line numbers to each of these instructions here. Let me just scroll the screen over so we can see it. Right there, and I'll zoom in a bit. So here you can see this welcome subroutine here. Sorry, let me move it into place here. Right here. So this welcome subroutine here, which I've indicated here as beginning at line 4600. And again, of course, this is a basic program. If we're programming in Z80 assembly language, we won't have to worry about these line numbers. It'll be a lot easier, but since this example does use Sinclair Basic, then we have line numbers we need to deal with. So let's take a look at this welcome subroutine. And the purpose of it is right here, print welcome message and prompt for player input. And we can see here the pseudocode for that, or there's the regular English instructions. It says it clears the screen, it prints a welcome message, it prints the current high score with the player name, and you can see I've got the variables here outlined, or rather highlighted in green. And if we look back at our variables page here, we can see that I've got my global variables highlighted in green, and then my local variables highlighted in blue, just to make it a bit easier to see what types of variables we're dealing with here on our code page over here. So for example, we can see here that this subroutine uses two global variables, this one called high score and this one called name, and it's very easy to look at these variables on our list if we wanted to see what these variables do, because they're all in order and they're global variables here. So if we look for those, high score and name, high score is right here, high score, and it has a starting value of 100, and it is the high score of whichever player achieved the high score. And then our other variable name here is the name of the person who achieved the high score. So very straightforward. All this subroutine does is it clears the screen, prints a welcome message, which includes the name of the high score player as well as their score, and then it prompts the player to press a key to begin or to exit the program. And then of course it returns. We need to make sure we put that return instruction there. And here is the code to accomplish all of those tasks. So I've just gone through and I've included all the code to do those different things, and I've put line numbers here beginning at line 4600. So now if I copy all this code just like that, and I want to go back to my editor now, and I want to paste it into our program, and since this code starts at line 4600, I'm going to put it in the correct place, which will be right here between line 311 and line 1100. So I'll just go ahead and paste that in now. And there we go. We have line 4600 with all the code for this subroutine. And I have a rem statement here, which just indicates what the name of this subroutine is. It's called welcome. So this is my subroutine called welcome. And let me see here. So I should have a variable with the name welcome assigned to it with the value of 4600 where this subroutine begins. So let's take a look at the initialization portion of my program, which is right down here. And if we take a look here, we can see right here we have a line number of 8390, which assigns a value to this variable name called welcome. So this is where my welcome subroutine, it's at line 4600. So if I want to call this welcome subroutine, I don't need to call line 4600 or go sub line 4600, I can simply say go sub welcome because I have this variable assigned. So that's why I'm using these variables in place of line numbers, just to make my job a bit easier. So now if we go back up to my subroutine, we can see here that our subroutine called welcome begins at line 4600, and then in my main program loop at the top here, you can see line 104 here is where we actually go sub this subroutine called welcome. So right now it's commented out with this semicolon. I'll just get rid of the semicolon, and now this line is active. So if I go ahead and save this program now, and then we'll go back to our command window and assemble this program. So here we are back in the command window, and if I go ahead and run my batch file to assemble this program and inject it into the ROM image and then open our CSpec emulator, then I do that by typing build, which will execute this build.batch file here, just as we've been doing up until now. So we'll go ahead and try that now with our new modified program and see how it tests our welcome subroutine. And if we take a look here at the output, you can see we have an error message that says line 1100 rem ball erase. It says line numbers out of order on 1100. So it looks like I made a mistake entering these line numbers into my editor, which is good. It gives me this error message. So line 1100 is out of order. Let's go back and take a look at the editor. And let's see here. Okay, yeah, so you can see I've pasted this code which begins at line 4600 before this code that begins at line 1100. So of course 4600 is higher than 1100, so I've pasted these in the wrong order, but that's easy enough to fix. In this case, all I'm going to do is cut out these 3 lines of code from line 1100 to 1104, just like that, and then I'll paste them in order before my welcome subroutine up here. There you go. So now everything should be in order. I've got line 1100 and then line 4600. So let's go ahead and save this program. And now we'll go back and try to convert it again. Back in our command window here, and I'll type build again. And this time we don't get any error messages. You can see here that it's not showing any error messages, which is good. And it opened our emulator as well, right here. So now let's take a look at our program again, which is down here, my project.bas. And now let's see if it opens our welcome screen. And there we go. We have my simple welcome screen that I've designed here. I know it's not all that impressive, but it gets the job done, I think. So here you can see just a simple welcome screen that I've designed. It says the name of the program called Bricks with a Z, Spriteworx Studios. Can you beat the high score? And here's the name of the current player who has the high score, Sir Sprite, and their high score is 100. And then it shows the controls to use to play the game. I moves the paddle left, P moves the paddle right, and then there's a message here that says power bricks equals scoring bonus. So if you knock out a power brick, that increases the bonus that you get every time you score. And then finally it has a message here, press a key to begin. So it's a very simple title screen, and it's just kind of a placeholder that we can use to test this particular welcome screen module. And that's how we test the entire program. We just go through and we copy and paste all the code from all these different module sections into the editor, and we can test them one at a time. And we just need to make sure that we have all the supporting code and supporting variables already defined when we go ahead and test each part of our code that might be relying on some variables or some other subroutines. So doing it in this modular fashion, I think will make it easy for us to both build our programs to begin with and to troubleshoot them and test them and to modify them. All right, so it's actually been a few days, I think almost 2 weeks since I recorded the first part of this video. And I know this is a very long video, so I apologize. If you're interested in this type of content, then I'm glad you're watching it all the way through. I know I take a long time to explain things because I direct my videos for beginners. And if you are not interested, you can fast forward it if you like. But anyway, what I was saying was it's been, I think, about a week and a half since I've actually started recording the first part of this video. And I've since gone through and finished entering all the different sections of code into my Visual Studio Code editor. And I've gone through and I've tested all the different subroutines or modules, and I've done, I think, hopefully most of the debugging. So it seems to be working pretty much now the way I expected it to be working. And the one thing I want to just emphasize before I actually show you this program working is that I'm actually being very strict about sticking to my original outline, which is this one here. If we look at my original overview right here, and I'll zoom in a bit, or zoom in a lot. So remember, we started out with a very simple, ideally one sentence overall description of this game and what it was designed to do. And then we have a slightly longer description of the gameplay and exactly what the player can expect when they're playing the game. And then I have a list of basic features here. And so these features are the ones I want to stick to when I'm making this game. I don't want to be tempted to add any extra features until I get this core functionality working, because otherwise then it's tempting to just continue adding features endlessly and the program can get messy and complicated and it might never get finished. So my first goal is to finish the game with these features that I've got outlined here. So let's just see if I've done all that before I show you the game. I wanted 7 rows of random colored bricks. Well, I don't have random colored bricks. I've just got blue bricks for the regular bricks, and then the power bricks are purple. So I don't have random colored bricks. I don't consider the random colors to be a critical feature. So, but I do have 7 rows of bricks. Special power bricks are distributed randomly throughout the wall of bricks. I do have that feature implemented. The player starts with 1 active paddle plus 3 extras. I do have that implemented. Highest score is displayed on screen during gameplay. That's done. Current score is displayed on screen during gameplay. That's done. Number of remaining paddles displayed on screen. That's done. Level number displayed on screen. That's done. And you'll see all this in a moment when I show you the game. Extra paddle earned for every screen cleared. So I think this might be a new feature that I added. I'm not sure if this was an original feature that I had when I first started this video or not. It's been a while. But like I said, I try not to add too many extra base features. But if there's a base feature that is particularly easy to implement, or I consider to be kind of a critical feature that would really add a lot of value to the game without making it too much more complicated to develop, then I will add that. So this might have been an extra feature to add an extra paddle every time a screen is cleared, because that's very easy to implement. So that's been done. And then let's see, the player earns 1 point for every brick knocked out, plus a bonus based on the ball color. That's been done. Ball color changes to next higher color every time it hits a special power brick. That's been done. Hitting a power brick awards 10 times the current score plus a bonus, and then increments the bonus level. That's been done. Clearing a screen earns 100 times. Oh, this is a new feature that I added. Clearing a screen earns 100 times the current bonus count. So whatever your current score would be for hitting a brick, so you get that 1 point plus whatever the bonus is. So maybe the bonus level is 3, then you get 3 points plus 1, so that equals 4. Once you clear the screen, you get 100 times that amount. So I have implemented that. And then the bonus value and ball color changes revert back to their lowest level when the player misses the ball. That's working. The ball changes color to indicate points multiplier. That's working. It's actually not a points multiplier. It's actually a points bonus. So I'll just change that. All right, so that's done. And this is just a chart of the different ball colors and their points bonus. Actually, this is a bit different, because if you see here, black gives no bonus, which is correct. Blue, and then it cycles up through these different colors: blue, red, magenta, green, cyan, and yellow. Well, there is no yellow because my screen is actually yellow. So I've removed this yellow color. The ball never changes to yellow. It just cycles from black through to cyan. And so that's it. All my critical features, my base features, are now implemented in the game. And I still have some extra features here I could add later if I want to, either to maybe sequel to this game or maybe a deluxe version of this game, and you can come up with a list of bonus features as the game is being developed. And it's a lot better, I think, to do it that way rather than just sitting down at the keyboard and starting to code a game from scratch and then just keep adding features as they occur to you, and then the game never gets done. So now my game is actually playable and my core features are all done, but the graphics are not done because remember, I have an assets list here where I have all the different assets that need to be created, which would be things like graphics, pictures, maybe background scenes, tiles, sprites, sound effects, music, different assets that need to be created. Those don't need to be created up front because they're very time consuming, particularly designing graphics. So there's not much point in designing some complicated graphics when you decide maybe you don't need them or they don't fit in your memory or whatever. So I save the asset preparation until last for the most part. So I haven't designed the graphics, but the game is functional. So let's go ahead and take a look at it now. So I'll just run it here. And it's converting the text file into BASIC. It's injecting it into the ROM image, as I've mentioned before. It's opening the CSpec emulator here. We can see here is the opening screen. I've redesigned it just slightly, just moved some things around. Again, I don't like to play around with the graphics too much until the game is actually playable because it takes a long time. And even actually just redesigning these simple changes I made to this opening screen took a long time, but I'm picky with the graphics. Even though I know these graphics are not impressive, but even these simple graphics, I'm still picky about getting them to look the way I want. So here we have the opening screen for the game. It says, can you beat the high score? Very simple instructions. Name of the high score player who's currently obtained the high score. Their name is Sir Sprite, and the high score to beat is 100. The controls are I and P for left and right. And then it has a note here saying the power bricks give you a scoring bonus. And here you have the option to press S for start or Q for quit. So first of all, let me press Q because I want to show this final ending message of my game, which is like a credits screen. And here I want to thank some contributors, particularly I have some patrons that are contributing to my game development, which I really appreciate. As you know, I'm not doing this for money. I really want to give back to the community, both for providing me with this fantastic computer and letting me relive an enjoyable part of my youth, which was learning game development on the Sinclair computers, or Timex Sinclair in my case. And so anyway, but I do have a Patreon site, and I do have a few backers on my Patreon site, which I really appreciate their support. And here are their names. Vince Andrews, he's a monster backer. So if you haven't seen my Patreon site, feel free to go check it out, and you can see the different levels of membership if you're interested in helping to support this site. But again, I'm not doing this for money, so feel free to just watch the free content on my YouTube channel because it's always going to be free, and I plan to never monetize my YouTube channel. But I do want to acknowledge the support of these generous backers. Vince Andrews, who is a monster backer. Tim Buchalka, sorry, I don't know how to pronounce it properly, but he's also a monster backer. And there's Robert Beaver, who is an intrepid hero, and Scott Ager, not sure how to pronounce that either. And I'm just calling him a contributor. Contributor is not a level on my Patreon site, but he provided some valuable feedback to me in one of my live streaming sessions. And so he rated thank you on my credits for this game as well. So if you're a patron of mine at any level, you get to see the videos at least 1 week early. And then the different levels provide different other rewards, such as membership in my private Spriteworx Facebook group, where I've got downloadable content. This basic program, I'll be uploading it to my Facebook group for the patrons who are subscribing at this intrepid hero level or higher. They get access to the group. So I want to thank all my supporters again for that. It's very generous and I appreciate it. And now let's go ahead and start the game. So I'll just run it again. All right, so if I press start now, there is the screen being built and the bricks are being printed. We can see the regular bricks are in blue and they have the placeholder graphics K and L because they're using user-defined graphics K and L. And then the power bricks have characters M and N, which I'm printing in magenta. And there's a message that says press L to launch the ball. And you can see my paddle down here is a strange mixture of characters. It's a triangle and then two character C's and then the character D. So right at the bottom of the screen, you can see the paddle shown there just as characters. And so let me press L to launch the ball now. And now I can move the paddle left and right and catch my ball. And my ball is just shown as a triangle right now because I haven't defined any of the graphics yet. But you can see that the main game functionality is working. And so by following this development workflow, I was able to go through and get all this functionality working, get the different features implemented, and get the bugs removed to get this functionality working. So now I essentially have a completed game. And all I need to do now is finish designing the graphics, which I will do next. And I just want to wait until this thing hits a power brick, if it will. And it's actually kind of fun to play. I always enjoyed making breakout games because they're fun to code and they're fun to play and they're fun to modify, and there's so many there. So I hit a power brick and you can see now the ball changed color to blue, which I think is kind of a cool feature. And every time it hits a power brick, it changes color to the next higher level. And as long as you don't miss the ball, it just continuously increments the colors and increments the bonus value. You can see the bonus now at the top center. It says bonus 1. So now we get 1 extra point every time we hit a regular brick. And then every time I hit another power brick, which is those purple ones, then the score bonus will increase. And it will keep doing that. So now it's changed to red. You can see we're at bonus level 2, which is color red for the ball. And now we get 2 extra points every time we hit a regular brick. And so there's the game functioning with placeholder graphics. And now I'm just going to go through and design some actual graphics for these user-defined graphics characters. And then we'll try the game again and see how it looks. All right, so I've finished designing the graphics for my game. And first of all, let me say, if you're still with me by this point in the video, then thanks very much. I know it's been a long video and I appreciate your patience and I admire your patience. But I'm hopeful that this video will be useful for at least some of you to help at least get you started on the road to developing some games and actually finishing some games, because I've seen a lot of games out there that have been started, but I haven't seen them finished yet. So hopefully there is a workflow in process, either it's mine or someone else's, that actually is able to get these games out in the public so we can all enjoy them. So as for my game, it is finished now, at least with the features that I've set out from the beginning in my development outline. And let me go ahead and show you the graphics that I've created now. They're very simple graphics. Like I mentioned, they're just user-defined graphics. And here they are. So you can see here we have just some simple bricks, a couple different patterns of bricks, and a basic outline for the wall, and just the simple text. It's not fancy graphics, but it works. And I'm just going to show you how I created them before I actually go ahead and play the game. And the way I did it was I used this free online program that I've shown you before in a previous video called Piskel. And what I did was I just laid it out so that I had the graphics available to me in these size of squares, where I could just simply highlight the different pixels that I wanted to be showing right here. So there you can see the different graphics that I've designed for this game. And here is the screen for the outline of the playing field. And you can see the different characters that are designated for the user-defined graphics. And then these were converted to the actual characters right here in my game. And here, for example, you can see the ball in the top left corner, and then the different bricks and the different elements for the wall designs and so forth. So everything is here, and there's even a couple new characters that are not included in this game yet, but I'm planning to include in the final version of the game, the full version. So this demo version that I've just used for this video today is a bit limited version, and I'm going to be actually creating a full version of this game. It's not a very fancy game, and it's certainly not optimized for its code or anything like that. It's just my first game, so I don't expect it to be fantastic, but it's complete. So I'm glad it got to that point. And now let me just show you how I actually got these graphics into my game. So here you can see, if I zoom in on one of these graphics, for example, here is the ball that I used in my game. And so these squares obviously represent the pixels, and all I did was simply convert these pixels to bits or binary digits, which are in my game notes here. So back here on the assets page of my game notes, you can see I have the ball character identified here, and this is the pattern of the bits that I used for it. So I simply transferred those bits from my graphic over to this chart here, and so these are all the individual bits. And then what I did was I took these bits and I transferred those into my program, or my program listing rather, which is right here. So this is the listing I have to identify the graphics characters for the ball character, which is the user-defined graphics character A in this case. So then I took this set of code and copied it into my Visual Studio Code editor, just like I did with the rest of my program. And that's how I created the graphics for this game. So now let's go take a look at how it looks like when the game is actually playing. Alright, so here's the game now, and if I launch the ball by pressing L, you can see it has the same mechanics as before when we were just using the placeholder graphics, but now it has graphics that actually look like what they're supposed to look like. And now essentially the game is complete. So there, I hope this introduction to my game development workflow has been useful for you, and I'm going to upload a copy of this game to my Spriteworx Facebook group for my Patreon subscribers, and I'll also be uploading probably a couple versions of this game to my Spriteworx itch.io account as well, for anyone who wants to download it there. There'll be a free demo version and then probably 1 or 2 paid versions with different features. So if you're interested in checking it out, feel free to download the free version and play around with it if you like, or you can take a look at a more advanced version where I plan to introduce some new features. Alright, so there you go. You have my introduction to the game development workflow that I've come up with for at least starting to develop my games, and hopefully it'll be useful in helping you develop your games. And as always, thanks for watching, and we'll see you in the next video.